changes will be happening. You're just taking hydrogen and oxygen. So what happens when carbon dioxide gas is formed and water is formed? Formation, as they say, is a label. Okay, we can't take that to the reactions. So what are the changes that we have in terms of temperature change in temperature? Exactly. There is a change in pressure. Surface area. Correct. The surface area is more in terms of catalyst. So you can view the presentation, right? You're okay to sit there or not? There is a difference. So here we want to take an example of chemical reaction. Okay. So here I have taken a calcium carbonate. Can you please say the molecular formula of calcium carbonate? Okay, what is it commonly called? No. Common name. I'm asking calcium carbonate is a chemical name. Commonly it is called as limestone. Is exactly. Okay. You just take your limestone. So once you are just heated. Okay. So once you are just heating it, what happens in the sense the calcium carbonate will absorb the heat, correct? So after absorbing the heat, it will be getting split into calcium oxide and carbon dioxide. Okay. So see, this is your calcium carbonate, CaCO3. Once it is just getting heating in the sense, it will be getting split into calcium oxide and carbon dioxide. Clear with this one? So this compound absorbs the heat and it will be breaking into calcium oxide and carbon dioxide. Okay. So here what is happening in the sense, this calcium oxide will be solid. This carbon dioxide is a gas. So it will be easily evolved from the reaction. So if a reaction is getting carried out in the sense, definitely there are certain gases like hydrogen, nitrogen, carbon dioxide, they will be easily getting released. And water molecule also can be separated from the reaction. And this solid substance will be settling down in the reaction. So do you know what is this thing? CaO, that is calcium oxide. What is the common name? Stated line or quick line? Quick line. What is stated line? Calcium hydroxide. Exactly. CaOH. CaOH twice. This is your plated line, and calcium oxide. This is will be your quick lime, and this is your limestone. See, this is not. It is not only limestone. The chalk piece that is made up of your calcium carbonate. Okay, yes. So this is your first example. Moving to our second slide. You already know about the reactants. Okay, so here you can see I have mentioned the word named as reactant and product. Okay, so take a simple reaction. Okay, in the previous reaction, this calcium carbonate is a reactant or a product? Reactant. Very good. Calcium oxide, product. Calcium carbon dioxide, it's a product. So reactant in the sense what happened? They both will combine together, and once after combining, the newly formed substance is known as product. Okay. Say for example, take your carbon and oxygen. Okay, oxygen is a gas. What about carbon? Solid. You do you know that carbon is what are the available forms of carbon? Coke. Okay, and the mining, the impurities that is mined from our earth. In Tamil, they will say it as nilakari. That is carbon, coal, exactly coal. That is your carbon. So just take the carbon. Actually, you may ask the question, what is oxygen we are just using? Carbon plus oxygen in the sense, the combustion reaction will take place. Always do remember, in combustion reaction, oxygen will always take an important part. Because in our surrounding, oxygen is there. Correct? Always it will help in the combustion reaction. So take your coal and heat, immediately carbon dioxide gas will be liberated from that coal. Okay. This there will be a just take a little amount of coal and show it in the flame. Your gas will be just the fumes will be getting out is nothing but your carbon dioxide. So carbon and oxygen will be your reactant and carbon dioxide will be your product. Likewise, see here, what I have said is, in the previous reaction, calcium carbonate into calcium oxide and carbon dioxide, that calcium carbonate is your reactant and calcium oxide and carbon dioxide is your product. Okay, so now coming to the second one. See, I have taken sodium with water. Okay, when I'm dropping sodium in water, the reaction is very smooth. What happens? Huh? Why it's quite vigorous? Why it's highly reactive? There is a reason. It is highly reactive. Why it is highly reactive? You're right. Huh? What is a valency? Then high valency. What is valency? Combined with other elements. Okay, valency. What is it? No. It's not pH value. Valency is different from pH value. pH is a scale which is used to say whether the substance is acidic or basic. That is different. That is a concentration of H plus ions. That is pH. Here, he said, I'm asking sodium, when it is reacted with water, it is forming sodium hydroxide. This is actually a highly vigorous reaction. So he said it is highly reactive. It is vigorous. I'm asking why it is highly reactive. Again, he is saying high valency. So valency is the state which is combining with other elements. That is fine. Now my question is, what is the valency of sodium? Can you understand my point? What is the valency of sodium? Okay. Huh? No, not 8. Okay, what is the atomic number of sodium? I think you have learned this atomic number in your previous class itself. What is the atomic number of sodium? K shell, L shell, M shell, N shell. Number of electrons filled in K shell will be 2. Correct. So K shell is the first 2, 8, 2. 2, 8, 2, 12. Probably 12 is the, are you right? Almost you're close. No. 11. You're exactly right. 11. So in K shell there will be 2 electrons. Okay. In L shell it will be 8 electrons. And in N shell there is only 1 electron. Now connect the dot. What he said, it is highly reactive. When the element will be highly reactive? Exactly, all right. So when it is having less number of electrons, okay, fine. When it is having less number of electrons, what is the advantage of that electron? No, in the shell. I'm asking in the shell. See, if this is your sodium. So in first shell there is 2 electrons. In second shell there is 8 electrons. Okay. In third shell there is only 1 electron. The benefit of having 1 electron is that electron can move freely around the shell. Once it is freely moving, what can it will do? Okay, that is the nature of metals, right? So metals can easily donate electron in the sense, once this electron is easily donated means this can become stable. Correct? This can become stable. Because of this 1 electron only, this is highly having the conducting electricity and they are having the characteristics of metal. Now you said it's highly vigorous because of this 1 electron. Now my question, we are having our salt, table salt, sodium chloride, but that kind of vigorous thing is not happening. Where? No. I'm saying. Exactly. Combine. So, okay, you're correct. Combining. Then what happens? Exactly. So the oxide is filled. They are becoming stable. So this sodium, it is losing its 1 electron and it is donating to the chlorine. You can understand my point. See, sodium becomes plus. Na plus in the sense it is donated 1 electron and this chlorine minus means it has accepted 1 electron. So what happens? Both are stable. Both are happy. So at that time they will become unreactive. Have you heard about the inert elements? Inert gases. What is inert gases? Why they are not reactive? Exactly, they are completely filled. They are already formed the oxide. What you say? They are stable. All are. So very clever actually. Very good. Okay. Now coming to this reaction. So here I have taken sodium. When I'm combining with water, I can form a product sodium hydroxide and your hydrogen gas is getting released. Just look at this reaction. Is this reaction balanced? No. So here sodium is having 1 electron in the reactant side and here in the product side, sodium is having 1 electron. Oxygen is having 1 electron in the reactant side. In product is also it's having 1 electron. But the troubling element is hydrogen. So in the reactant side, 3. In the reactant side, only one. What is the element I have asked? Hydrogen. In the reactant side, how many? Just come closer. Look at here. How many? What is the number? H. Come here. H. 2. So two electrons in the reactant side. So look at here in the product side. 3. So here 2, here 1, 3. So this reaction is not balanced. Okay, now the question is, there is one of the just consider. You have a better question. Okay, yes. So now my question is, if this reaction is not balanced in this sense, okay, this reaction is possible, but there is no mass. Okay, have you heard this thing? Atom can be neither created nor destroyed. Okay, so how much number of atom you are taking, that much number of atom are be correct with this one. So here you have taken 2 hydrogen, but here there is 3 hydrogen. So this is actually violating the rule. Okay, so in this case, you have to balance the reaction. Okay, so thus that we are going to see in our next slide, moving to our third slide. So similarly, this is also saying about balancing. We'll be seeing in another 2 or 3 slides. So we can first brush all the basics. So now here, this is your reactant and this is your product. And now, see, in calcium carbonate, how many elements are there? Elements. That is the one compound. I'm asking how many elements are there? 3. What are all the elements? Oxygen. So definitely, if it is making it as a compound, some sort of force is there that holds, if calcium is a major element in the sense, some sort of force is there to take the carbon and to keep the oxygen with itself. That's why as such we are just saying it as a compound, correct? So when it comes to that point, there is some kind of force is there. So definitely there is a bond also in between them, correct? Calcium, carbon, oxygen, all three different elements are present means what happens in the sense there is a bond between all the three elements which is combining as a compound. Now that is your reactant. Now you are heating. Once you are heating in the sense what you are doing there? Huh? Sorry? Okay, heating in the sense combustion. Okay, I'm just giving the oxygen. So what is happening there? That compound is breaking. Okay, the bond is breaking. So the bond that is connecting your calcium, carbon, oxygen is completely getting break. And what happened? Your oxygen is just getting, your carbon dioxide is involved in the reaction and your solid calcium oxide is present there. Okay, so all these elements are connected by a bond. Okay, so that's why what happened, your compound is getting formed. Even if you're just taking the elements like oxygen, O2 and nitrogen, there is two oxygens present. So definitely the two oxygen are connected by a bond, correct? Yes. So now that is what the thing, atoms in the molecules are held together by the force of attraction is called bond. If you're just taking calcium, there is a bond and carbon dioxide. We can draw the structure. Okay. So this is a type of bond. Once you're just heating, what happens? All this bond is getting break. After that, what happens? Easily the evolving gas will be getting out of the reaction, carbon dioxide and your calcium oxide will be. Yes. Okay. Now, the molecules do not participate directly in a chemical reaction. Actually, okay. So, if no issues, it will happen. Okay. If calcium carbonate is there in the sense, calcium carbonate initially will go on easily, it will just participate, can't participate. Why? In the sense, first this calcium carbonate will be breaking into pieces. Okay. So then only what happens? What are all the possibilities is there? If there is a gas, it will be getting evolved. If there is a water, it will be getting eliminated. So likewise, that is the first step. And in second step, what happens is, see, here there is a bond between three elements. But in the product side, calcium oxide is a bond between two elements. And carbon dioxide is a bond between two elements. So the bond is different in terms of reactants and the bond is different in terms of products. The new bond is also formed, but there it is three elements, here it is two elements. Okay, yes. And what happens in the sense, the atoms will rearrange themselves. If you're just taking calcium carbonate, they will rearrange and they are forming your calcium oxide and carbon dioxide. Whenever a reaction is just taking or carrying away the sense, what happens? The gases is the first thing to escape. Carbon dioxide, oxygen, hydrogen, nitrogen, then your water molecule, then your solid substance will be there. Okay, so here your possibilities, your gases will be getting escaped, then your solid carbon dioxide, carbon oxide, that is calcium oxide will be remaining. Clear with this one? Yes. So now we are moving to our fourth slide. Here comes our next part, balance. You said about valency, right? So the combining ability. If sodium is having the valency of 1, with that 1 electron only, to give 1 electron to the fluorine. So it is getting combined. Okay. So now likewise, you know about periodic table? Yes. So what do you know about periodic table? Classification of elements, order of number of. Okay, elements. Yeah, that's fine. What do you know about periodic? Any information about periodic table? Exactly, very good. Consists more than 100 elements. Anything? You can just write, or else I'll say no issues. Okay, fine. So periodic table consists of n number of elements. So far there is 118 elements they have discovered. Okay. So each and every elements application orientedly we are just using in our day-to-day life. So there actually they will be just separating the elements as in the leftmost side of the periodic table. In the leftmost side of the periodic table, you can see the most reactive elements will be present. Okay. So in the rightmost side of the periodic table, you can see the non-reactive elements and the inert gases will be present. Okay. So wait, I think like here there is no periodic table is attached. Okay. So okay, I'll just teach you here itself. See, if this is your periodic table in the sense. In this stage, it will be present. Okay. Huh. So now this is your periodic table, and in this periodic table, see your lithium, sodium, potassium, rubidium, cesium will be present here. Okay, so here you can see beryllium, magnesium, calcium, strontium, barium will be present here. Okay, just don't get confused. I'm just trying to give you the information about this thing. And here you can see all the transition elements will be present. Transition elements in the sense gold, silver, platinum, mercury, everything you can find here. And here you can see carbon, oxygen, nitrogen. Okay, this is boron, and your noble gases like fluorine, and finally your neon will be placed here. So these kinds of elements are quite not reactive. And coming to the last table, this noble gas, it is completely inert. They are stable in nature. So if you're just taking this kind of elements, it is not reacting. This kind of elements will be having extreme reactivity. So that's why they have tabulated the periodic table as highly reactive elements in the left side. Okay, and moderately reactive elements in the center. Okay, and the more unreactive, like less reactive elements in the right side. The last table is noble gases, your inert gases, that is, they'll be stable, they'll be not reactive in your last. Okay, here they'll be placed. So here there is not called, you said about balance. Another term is known as group balance. So if I'm taking sodium, okay, so for sodium, the atomic number is, for sodium, the atomic number is 11. Okay, so when it is 11 in this sense, the diagram will be, there will be 2 electrons here, 8 electrons and 1 electron. This 1 electron is the valency. So the valency of sodium is 1. Okay, so likewise, if you're just taking potassium, so where is the potassium is there? Below sodium. Okay, so what will be the valency of potassium? Huh? No, you're saying about the atomic number. Even if it is atomic number, is also that strong. Not okay. So now, if you're just taking magnesium, magnesium is having an atomic number of 12. What is the valency? 2, exactly 2. Okay, so say for I think this is your magnesium Mg. Okay, so this is your valency 2. Okay, so now I'm moving to my next one. That is here. If I'm taking boron, what is the atomic number of boron? Any guess? 5. You're right. Correct. You're right. 5. So what will be the valency of boron? So in first shell, K shell, exactly, in K shell, 2 electrons, and in L shell, totally 3 electrons will be there. The valency will be 3. So this is what valency. Each and every element has its own valency. So what will be the valency of carbon? If boron is 3 means carbon will be 4. Oxygen 5. Nitrogen 6. Fluorine 7. Noble gases 8. Can you understand the thing? Okay. So now take this fluorine. What is the valency of fluorine? 7. So if it is having the valency of 7 means how many electrons is needed for this fluorine to fill its octet? Only 1 electron. Only 1 electron. 2, 7. So only 1 electron is needed for this fluorine. So there is another one more word called electronegative. Electronegative means the tendency to attract the electron. So this fluorine will be highly electronegative. Among the periodic table, this fluorine is highly electronegative. Why it is highly electronegative? Because only 1 electron is necessary to complete its octet. Correct? So at the end of the day, every element will try to achieve the stable gas confidence. In our life also stability is necessary. We will go home, we will eat, we will stability. Right? So likewise, these elements also try to find out the way for the stability. Okay. So likewise, for nitrogen, how many elements is needed? How many electrons were needed for nitrogen? See, for fluorine, no. Listen. For fluorine, there is only 1 electron is enough. For nitrogen, 2 electrons. Correct? So this is what the thing, right? Yes. So likewise, just read the thing. Chlorine atom can share 1 electron. See, below fluorine, chlorine will be there. And you will be having a doubt. Fluorine is having the valency of 1 means whether chlorine will be having the valency of 1 now. No. See, fluorine is having the valency 1. I'm talking about the valency. So chlorine will be having similar valency of 1. Okay, shall we write the atomic like electronic configurations? No? K shell, L shell, M shell, N shell. So for chlorine, the atomic number is 17. I'm disclosing. So in K shell, 2 electrons. Okay, in L shell, 8 electrons. Then 8 electrons. So totally 8 plus 2, 10, 18. So chlorine is having 17. So in other shell, 7 electrons will be there. Okay. So in the third shell, totally 8 electrons should be there. But chlorine is having only 7 electrons. So how many electrons is needed? 1. So that is what chlorine. So this is known as group balance. Group balance in the sense, see, if you are just taking for sodium, the valence is 1 means, okay, this lithium, sodium, potassium, rubidium, cesium, everything will be showing the group balance of 1 only. Okay, so no. Yeah, coming to the reactivity will be there. You have to see only in terms of valency. Valency in the sense, here there is only 1 electron. Reactivity is based on how freely can electron move around the shell. In terms of fluorine, there is 7 electrons. So the fluorine will be reactive. If it tries to only attract the electron, reactivity is different. Fluorine is a non-metal. Okay, so what happens means, because actually it needs the stability. So wherever there is 1 electron, it will go and attract the electron, it will be stable. Correct? So till that thing, the fluorine will be having a kind of fighting thing. Okay, it will be quite violent. That is why it is known as highly electronegative. So in case of the sodium, only 1 electron is there. If I'm having only 1 electron in the sense, see, if I'm carrying only 1 baby means I can move freely around this space. If I'm having 7 babies means it is quite hard. So similar kind, sodium is having only 1 electron in the valence shell. Imagine, see, this is your valence shell. If there is 1 electron means it can freely move around here. What is electricity? The free movement of ions. Okay, how freely the electron move from one place to another. So that's why it is known as metals or the good conductors of electricity. Why it is good conductors of electricity? Because they can freely move from one state to another state. Clear? Can get my point? Yes. Shall we move on next one? Any doubt? Okay. What will be the valency of magnesium? 2. Okay. What is the valency of carbon? Anyone? Carbon? 4. 4. Okay. How 4? Okay, so how many electrons in the K shell for carbon? K. L. 4. How you are saying 8? Okay, just take your note. Okay, and just take your note and write the K, L, M, N shells from lithium to fluorine. Okay, do you want your atomic number for lithium? It's 3. Okay, from that you can just go in an increasing order. Lithium 3, beryllium 4, okay, boron 5, carbon 6, oxygen. Okay, wait. Here it's boron, carbon, nitrogen, oxygen. Boron, carbon, nitrogen, oxygen, fluorine, and noble gases. Yes. So, guys, is it easy for you to catch everything? Can you catch everything? If there is any doubt, please ask. Okay. So if you're strong in your basics, means it is easy for you to understand the concept and to move on. Okay. Yes, yes. So the number of electrons present is only 2. So now, here are only the problems arise. Now, you want to then I will say the so there is only 2. So here are the equation of the number of electrons will be there. This calcium, 1 yes. Okay. There is only quantity. There is no complicated. That one electron can be one electron. So lithium, sodium, potassium, magnesium, potassium, lithium, all the three are barium cannot say barium is the one. Because of that one quantity and when we have the number two. So for the valency, so here you can see fluorine. So now here fluorine can share one valence electron. Its valence is 1. So oxygen total number is 105. Correct? 6. So here the valency of oxygen is 6, but we will be saying the valency of oxygen is only 2. Exactly. It is easy to get. So what happens when we try to give the electron? Use and here all three parts. What happens? Let me just the tendency of metals is to donate. Okay, so here there are one metals. Here carbon is only you share make a one. So what is sharing? So carbon one is sharing. Now, oxygen is having valency 2. Nitrogen having, what will be the valency of nitrogen? 5. How many? 3. So next one, therefore carbon 4. Very good. Carbon is 4. So carbon 4 electron, what it will do? Gain share. It will share. So that is what in this slide they have mentioned. Clear with this slide? Okay. Keep this in mind. Very important. Okay, now, moving to our next slide. It means, see, here I have taken C here. Carbon. How many carbon is there? How many chlorine is there? 4. 4. So 4, according to math term, how will you determine 4? Tetra. Tetra. Okay, just now. So this chlorine valency will be for carbon. So now, and try to cross validate whether it's getting worked out or not. Yes. So possible or not? Yes? This is hydrogen sulfate. It's all your friends. Oh, your kids. You're enjoying this class? Yes? Now we've got a picture of compost is forming. Yes. So this is also one of the important things. See, if you're taking the reactants and products, so then what happens? How the product is getting combined? Say for example, calcium oxide. There is calcium oxide. So 1 month. How is your oxygen is? Calcium 2. Yeah. What happened? Okay. Interesting. Now we can do the next one. Here with this one. So here, moving on next slide. See. Yeah. So now you can see a list of elements is present here. Correct? Yes? Okay. So I have written something else known as charges. What is charges? We know nucleus. In nucleus there is protons, neutrons, electrons. Protons are positive in charge. Electrons are negative in charge. Neutrons are quite neutral. Okay. So that is different. For each and every element, there is something known as charges is present. This sodium is present with Na plus. Sodium is providing, is giving 1 electron. There is only 1 electron present in sodium. likewise, if it is gaining means, okay, how we will be representing? So can you write? Right. For lithium, it is plus. Okay, it's for beryllium. Lithium. Beryllium. Boron, it will be shared. Clear? Now we can move to the next one. Yes. So here you can see I have represented many compounds here. Okay. Copper. I have written it as plus. So do you want to know why copper has got plus? What is the atomic number of copper? Anyone? 60. 16. Not 16. Open your book. Do anyone have your periodic table with you? No. Yes, open. That which is very useful for your competitive level. Okay, this is not 29. Very good. So how will you fill this 29? Do you know how to fill copper 29? Copper is 29. Okay. Before that thing, don't limit your thoughts, engage your thoughts within your text. I'm going a little bit higher. Okay, there is 3 rules to fill electronic one. See this here is okay, shall we go a little bit higher? Okay, there is 3 rules to fill this electronic configuration. First one is Bock principle. Bock principle. All the exclusion principles. We all need to even that okay, so this is your output. Means see always your lower energy, lower level should be filled. See what you are studying. These are on the electronic configuration of electronic chapter. Instead of okay, that K will say K is the first shell, L is the second shell, M is the third shell, N is the fourth shell. My question is, okay, what is the shape of the electron? Round, spherical. It is spherical. Round. Okay. Actually, we have to say it in a defined term. You have to mention it as spherical. Fine. So now this is all 360 degrees will be rotating the electron. P in the sense we can't see atoms. We can see atoms. We can't see in this chalk is made up of atoms. Yes. Okay. So definitely, if it is made up of atom in the sense it has nucleus, it has electrons, it has protons. Correct. So the electrons we can't say here in this chalk the electron rotates only in a spherical plane. We can't say. Okay. So likewise, you may ask the question: how can we visualize? Non-organic chemistry. You are right now studying chemistry in 11th standard. Okay, because here what the transition you are seeing is very less. When you are stepping into 11th standard, there will be huge transition. Okay, at that time definitely you people have a little kind of panic. So that's why to break it is class. Okay, first of all, you know, the visualization follows three types of chemistry. So in this chapter, you'll be studying so this P, which means the electron is rotating around the shape. P is flowing. That is coming down. Dumbbell shape. Sorry? Electron and electron, what happens? Attraction or repulsion? Repulsion will be taking place. One will be rotating like this. One will be rotating like this. Right? Where is it? Okay. So now, the number of electrons now, if you're taking a this is your electron. That is what I have written here. So yes, in the sense, don't read. Correct. And this is your D dot from stand to D dot. So count how many rows are there? How many rows are there? 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, D we have to electrons. And D is having only 6. D. 1, 2, 3, 4, 5. And here, this is your electron. So D rows in electron we can accommodate, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How the electrons are filled. So fine. Take a deep breath. This is enough. Okay. Now we can come back to our portions. Have you got any doubt? Fine. Yeah. See now how many electrons are in sodium? Here, it is here. 2. 1 electron is only in sodium. So we have how much amount of electrons? Magnesium in this one. What happens? One. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because I know certain people are getting quite boring. lower energy, always lower energy. This one. So there is what you got? Shall I do it here? Another one more time. Why I have filled in this way? Why I have drawing in this way? Now, I'll say only one more thing and I'll 20 lines. So, okay, see. One is now, okay, they have been given copper plus. Plus means after when it is donating one electron, it will become stable. Okay, now we can check this out. Stability, this electrons will try to exchange them. Clear? Okay, so you will be having an elaborate expression in 11th standard. Just I have said very little things. Okay. So likewise for potassium. So below sodium, your potassium will be there. Valency of sodium 1. Similarly, so 1 electron it is giving. Very good. So below potassium, sodium will be there. Similarly, sodium will be having a valency of no, potassium. Potassium will be having a valency of 1. So it will be K plus. So silver. Now we will be having C. Below copper. Okay. So I said an explanation for copper. Why it is this? Likewise for silver also, in this table you can see why it is having this. Similar kind of things. Okay. Next one. Sodium. 1 electron it will give, so plus. Lithium plus. Or as AU is nothing but your, what is this thing? Gold. AU is gold. AG is silver. PT. Hi. Potassium is K. Okay. No issues. That's okay. Even when I'm, at your age, I used to say potassium like that only. That's okay. Fine. So, barium. Ba. So how many electrons it will be giving or taking? Gain or lose? Lose 2 electrons. So Ba lose. Wait. Lose means plus. When it is losing means plus. That is what the concept in chemistry. Why it is Na plus? Clear? Opposite. Keep it in your mind. Okay. Barium 2 plus. So similar in cobalt, you have to draw this kind of diagram and they'll be having cobalt 2 plus. So likewise, now understand. Yes. Whatever. You can try for this table. You can try for this table and you can check. Okay. So everything will attain stable whether it can gain or by losing. Clear? Yes. Now coming to the next one. 7th slide. So here it's a continuation. For bromine, chlorine, fluorine. So fluorine, it will gain or lose the electrons? Gain the electrons. Okay. So it is represented how many electrons is needed to fill the octet? 1. So it is F minus. So all the fluorine, chlorine, bromine, iodine. Look at here. Fluorine, chlorine, bromine. So what happens in all of these 4 cases? 1, 1. So that's why I have written. You can see this slide everywhere minus. Here. Now coming to the next one, oxide and sulfate. For oxygen, valence is 2 because once it gains the 2 electron, it will become oxide. So oxygen and sulfur, oxide and sulfur, it's 2. And for nitrogen family, 3. Clear with this one? Yes. You're running out of time. The time is over. 10 minutes is there. Okay. So you're feeling interesting or quite boring? Mixed reactions. Okay. Yeah. Because I know I have gone beyond something else and made you a little confused. No. Okay. So this is your foundation course. Okay. So it will be like this one. Be mentally prepared. We can make this little bit interesting. Okay. Yes. And coming to the second point, whatever you're teaching in your syllabus, they are trying to teach in your class, that is different from this. I will connect that. I will connect it, but I will teach something extra. So that only you're two people to someone who's different. Correct? So why have you chosen this course? To make your foundation strong, to prepare competitively. Correct? So you have to learn a little bit extra. Correct? So fasten your seatbelts and we can move for this one. Next one. Okay. Next one is test for chemical reaction. Okay. So, starting chemical reactions, reactants, there is 2 reactants. So, once the 2 reactants are reacted, what happens? So when the reactants are involving in the chemical reaction, there will be absorption of heat, there will be liberation of heat, there will be change in temperature, there will be change in pressure, and the catalyst what we are adding, it depends upon the condition. Everything is there. So that is what they have listed here. See, the first one is there can be either evolution or absorption of heat. Okay, there will be a certain kind of chemical reactions to it. What is absorption of heat? What kind of reaction? Very good. Absorption of heat. Absorption. Huh? Ah. Releasing is exothermic reaction. Okay, so do you think only these two kind of things will be happening in a chemical reaction? No, many more things will be happening. And the reaction must occur between fixed quantities of reactants. What do you mean by fixed quantities? Huh? Yeah, there should be fixed volume, fixed quantity should be there. So that only our product generated will also be equal. So that only our mass will also be getting equal. Correct? Yes. So coming to the next one, there must not be either gain or loss of matter. So if this because matter or atom or mass, anything in an atom that can be neither created nor destroyed. Okay. So if you're just making anything like that means clear? So coming to the fourth one, the product obtained as a result of chemical reaction must have properties different from of the reactant. What does that mean? So what does that mean? Huh? See, the reactants will be having certain properties. Product will be having certain properties. Both of them will be same. Why? The ions are exchanging, the bond are breaking, new bond is forming. If your reactant, what you have taken, it can be liquid or solid. The product can be anything of gas or liquid or solid. Anything it can be. The product definitely will be different from each other. Clear with this thing? So now we can move to our next one. If, okay, so before that, think something like we can see corrosion that is there in the rust. How is it happening? Okay, have you seen the silver metal? If you are exposed to air, what is happening? Reddish brown. This reddish brown is on silver, or it's on iron. There is a reddish brown powder, a flaky powder that is there. On sulfur, sorry, on silver, black. Okay, there will be a surface of a pale black color will be formed. On copper, green. How the green is formed? How the black is? What reactions happen? Oxidation. Oxidation. Copper and sulfate. What is there? Exactly. So air means what are all the things? Oxygen. Okay, when I'm see this is my copper metal. So this is when I'm just keeping this atmosphere. Here what happens? Oxidation means what happens? It will take the oxygen. Okay, so once the oxygen is taking means what will be happening on the top of this layer? This oxygen will come and settle. This carbon dioxide will come and settle. The moisture, that is the H2O present in the surrounding, will come and settle on the surface. Once they are all settling, this is our copper metal. So this all the oxygen will try to react with this copper metal. Once they are reacting, they will be forming a different kind of product. So if this is your after some days, there will be a formation of your copper hydroxide copper formation to be formed. So this composition, as is what happens, will be turned into green color. Correct? Color change will happen, not immediately. It will take some time. Likewise, what happens in iron? This is my iron metal. My iron. So this is my iron. And here is what happens is so this iron oxide will form. It will react with iron and so iron oxide and this part and that is nothing but your reddish brown flaky substance. So inert, that's it. If that powder is formed, after that there will be nothing will be that powder is formed on the top of the surface. Means after that, even if the oxygen comes, already there the reaction formed. So that will become stable. Okay, this reddish browny flakes will become stable. Clear? Clear with this one? Any doubt with this class? Already the powder is formed, the corrosion is taking place. Okay, that's it. So any doubt in this class? So I think just an introduction class. Don't worry. With this introduction class, we can't reach that. Okay. So in next class, we can see with your syllabus and we can solve some questions. So if you have any doubt, no doubt, have you learned something new? Okay. You feel quite interesting. Yes, really. Okay. Fine. Thank you so much. See you in my next class. And have completed some 8 or 9 slides. Next class I'll complete. Next class we can see the balancing reaction. We can do some balancing reaction. Okay. Thank you so much. Oh yeah, sure. Can. முடிச்சிட்டா கீழே வரீங்களா நீங்க வாங்க வாங்க Bye. Take care. ஒரு நிமிஷம் லேப்டாப் பக்கம் எடுத்து போயிடலாம் எனக்கு அந்த காமபடி நம்ம கிளாஸே போடுவோம் சரி ஓகே ஃபைன் ஓகே தேங்க் யூ ஹலோ ஹலோ எங்க இருக்கீங்க பாஸ்கர்? ஓ, அங்க அந்த வேளச்சேரி பிரிட்ஜா? ஓ, சரி சரி, வாங்க வாங்க. நான் உள்ள போகாதீங்க, நான் வெளியவே வெயிட் பண்றேன். வாங்க, சரியா? அந்த முன்னாடி என்ட்ரன்ஸ்ல வெயிட் பண்றேன், வாங்க.